Hello, I'm Alexandra Panayiotou, and in this video I will provide a short overview of algorithm for variant calling using binomial distribution, the implementation of which was a part of a research project for course Computational Genomics. Variant calling is a process of finding differences between the reference genome and the observed sample. It is widely used for variant detection, and there are many tools available. Tools used for this project were SAMTools and Pylo for Pylo file generation, and BCF tools call for generation of reference.vcf file for algorithm evaluation. Input to the implemented tool is Pylo file, and the output is VCF file. Pylo file is a text-based file that has a format that consists of 5 mandatory and 1 optional column. It has a sequence identifier. Every line has a sequence identifier, position in sequence, reference nucleotide at that position, number of align reads, bases at that position from align reads, and thread quality of those bases. VCF file is also a text-based file. It has a mandatory header and at least 10 columns, where columns 10, 11, and etc. refer to the sample used for variant calling. The VCF provided by this implemented tool has 10 columns because it uses only one sample. In the column ref is the reference base or sequence, and in the column alt is the variant call. The sample column shows that what is the allele combination, whether it is having a reference or alternative sequence. So the implemented tool processes following types of variants: no variation. The sample has the same base as the reference genome. The SNV, or single nucleotide variation. The base in the sample is different than the one in the reference genome. And indel, there is an insertion or deletion of one or more bases in the sample compared to the reference. The implemented tool uses binomial distribution to calculate probabilities for variant calls. For every Pylo file, the tool should Pylo file line, the tool should find 2 variants with most occurrences, and for example call them B and B prime. And n is the number of occurrences of both bases, k is the number of B prime bases. So the genotype of BP, there should be k bases or errors, and n minus k are correct. Genotype, if genotype is B prime, n minus k bases are errors and k are correct. And if genotype is BB prime, all n bases are correct. And the algorithm should find the most probable case and use it to generate a line in VCF file. So the algorithm is implemented in Python 3 using pandas and NumPy libraries. It should open up a Pylo file, and then for all the values of single success probabilities, it should create a different variant call file, write its header, and then go through the Pylo file line by line and parse it to get the information for every position, the chromosome name, position, reference symbol, and the sample bases and their qualities, and then based on those values calculate using binomial distribution the variance, the variant calls, and then write the line to the VCF file, and then do it again for the next Pylo line. Evaluation of the implemented algorithm is done by comparing .vcf files with the output of BCF tools call tool output. True positives here are the number of same variant found in both VCF files. False positives is the number of variants found in generated VCF file but not in the reference, and false negatives are the number of variant calls found in the reference but not in the generated VCF. And based on that numbers, the precision recall and F-score are being calculated. And those values improve with the probability of single success being higher than 0.6. Then they're pretty much stable until it reaches 0.85, where it reaches its peak, and then they deteriorate. So adding the possibility of processing and calling microsatellites and large indels is one possibility of improvement of this algorithm. Also the analysis of qualities and taking qualities of base reads into account for more accurate predictions of variant calls and sampling errors, and also adding the possibility of comparing multiple samples at the same time. So the link to the project code and the files will be in the description of this video. And thank you for your time.